Hello, friends. My name is Will Lifford, and I am super psyched to kick off our second session of the machine learning track, I guess is what we're calling it. I will give myself a sort of formal introduction in a second. Good morning, good morning. It's good to have you here, or good evening, wherever you are. I'll give myself a more formal introduction in a second. We won't wait too long because we're kicking off a little bit late. But it is all good. I am super, super excited for our content today. One thing I want to put out very front, that this is the second session of the track, and I will send the link to the first session. But you don't have to have done the first session in order to get something out of this session. The first session really was for folks that haven't done a lot in Python before. So if you are tuning in and maybe haven't watched the previous session, but have done some things in Python before, then you are in good shape. Oh yeah, okay. Hello from everybody who attended the first session. It is really good to have you back. It is an absolute joy. Okay, so I will drop the link to the previous session. If you want to go check it out, you are more than welcome to. And it might be particularly helpful to folks that haven't done a lot of Python things, but you do not need to have done that. That is purely optional, but it could help you in that scenario. Okay, so we will kind of just charge straight ahead. I'll do a little table setting. We have like 4 slides again, but as we did last stream, I think I asked everybody where they're calling in from and what the weather was. Now I want to know where you are and what the last beverage you drank was that wasn't water. Did you have some juice or like some hot chocolate or something? Let me know in the comments. So for me, I am calling in from Seattle, Washington, and the last thing that I drank was a ristretto, just a tiny little espresso drink. Let's see. I know intermediate Python, any other prerequisite. I'm going to say on the whole, no. Nothing that you can't kind of pick up as we go. The one big thing is we will be using a library called Pandas a decent bit, and we covered the library Pandas in the last stream. But it's not super complicated, and if you have some basis in Python, maybe you've already used Pandas, and if you haven't, I think I'm confident it's something that you could pick up if you play around with Python. It makes me so happy to see folks tuning in from the previous session. Okay, we got grape juice, we have coffee, good stuff. I'm going to drink some water. I held off drinking water so I could say that my last drink was coffee. Actually, I said last drink that wasn't water, isn't it? We have some folks just getting out of bed. I'm just thrilled this is the first thing you're doing with your day. Incredible. Okay. So as promised, we only literally have 4 slides, but we will use them to do some table settings. So, and this is one of them. This is one of our slides. So today we're going to be choosing and exploring a data set. This is kind of entry 2 in the Build a Machine Learning web app track. You don't have to have done number 1 if you have some background in Python. My name is Will. I am a software engineer at Google. I am also a coach at Major League Hacking. I am, as we learned last time, a Python enthusiast. And one fun fact about me is that I am unbelievably caffeinated. And let's see, folks are saying, is the live stuck for anyone? Okay, I'm glad that it's not stuck for most people. That's good to hear. Okay, so this is kind of our roadmap. Not yesterday, a couple of days ago, we did Intro to Python, where we covered sort of Python basics. We refreshed our memory, and we looked at this library called Pandas that we're going to be using a lot today. And today we are doing choosing and exploring our data set. Next time we'll be building and testing our model, like actually doing the machine learning stuff. And then in our last track, we will be integrating our model into a web app. So this is roughly what we're going to be looking at. We're going to be finding a data set. We're going to be doing some exploratory data analysis. We're going to be dealing with bad data, and we're going to be dealing with some categorical data, which is all super cool stuff. And I guess that's the last slide, so I can now just go back to just talking. Let's get my screen off of the stream. And so before we get rolling, I think it's probably that you're tuning into the second session of a 4-part series on machine learning. And I think it's fair that we actually talk about why we have not done any, strictly speaking, machine learning yet, right? And I think that it's important to talk about sort of the machine learning life cycle. I think a lot of people, when we talk about sort of like the life cycle of a machine learning project, we will start with having to understand a problem, right? Like you are a business person or an academic and you have a problem, and then you go and you find some data, and then you go do some machine learning with that data. That's kind of like the really rough arc that people usually give. But I actually think this is like misleading for a lot of people, because oftentimes you actually don't have the data that you need to solve some problem, right? I think that's a great methodology, but I could come up with like 100 cool machine learning projects, and I would realistically be able to get the data I needed for maybe one of them. I know it's like a truism. We say that data is really valuable, but it is, and it can be really hard to get sometimes. So if you are a student or you are working in industry, I think it can be helpful to start by just looking at what data do you have. And so that's really going to be our kind of first stop on our journey today. We're going to be looking at some cool places to find some data. But I do want to call out that we're kind of eliding, or we're kind of waving our hands over, why do we want this data? What are we going to do with it? I've promised you we're going to do some cool AI stuff, and we will. But that's going to be next time, and we'll kind of zoom out and talk about, you know, all the nerdy, mathy machine learning stuff that you could possibly desire. Before we really dive in, actually, I want to follow up with a few things from last time. Good morning, good evening, everyone. It's so good to have you here. So a couple pieces of sort of previous stream housekeeping. Again, if you did not make it to our last stream, no worries. But thing number one is I wanted to drop this feedback form. For me personally, I want to, if you have specific questions or you have like feedback on something that I did well or could improve on, I would love for you to drop it in there. The other thing that I wanted to follow up on is my fish, which are kind of now another character on this stream. And I think I promised that I was going to set up a fish cam, and y'all, I set up a fish cam. Look at that. Look at the fish. Shout out to Blahaj fam. Yeah, shout out to all the Blahaj fam folks that are here. Fam folks, that's a technical term. So something that I had promised is that I was going to sort of raffle off the ability to name some of my fish. I have 5 neon blue rasboras, and I have given you not 1, not 2, but 3 ways to win the naming rights to one of these beautiful little fish, none of which have names at this point. And your 3 opportunities are: 1, attend each of these sessions and fill out a form for me so I know that you're here, which we'll get to a little bit later. The second opportunity is to win our machine learning contest that we are going to touch on in a second. Actually, I'm actually going to reveal that today. And then the third way is by making the best meme of some stream I've been part of. I love being memed. It makes me feel good. So meme something up, and if you have made the best meme, then you can also name one of my fish. So that's kind of the fish cam thing. I will probably go back to fish cam if I need a break. But we can go back to just my floating head here, and I will get things rolling. One note is that I am going to somewhere in this stream say some special word that you have to include in that form that I dropped in order to count as being in attendance for this stream. Also, if you want to go back and watch the previous one and you want to enter in a submission, then you can still do it. So if you didn't watch the first stream, you could still name a fish. And we're just going to raffle that off to somebody who's attended all the streams. Okay, without further ado, let's talk about where do we get our data. And there are 2 big sites that we're going to talk about today, where you can go and get your hands, get your grubby little mitts on some quality data. And the form is for feed of this or prev stream. So it's the same form for all of the streams, and you will just click a radio button saying this is the stream that you're attending. So yeah, all good there. Yes, the model building session will be next, and the integrating into web app will be the last one that we do. And actually, when we get there, that will be actually when we when I dish out naming rights, because we will have finished the competition. We will have finished all of the streams, or we will at least started all of the streams, so we can do some naming then. Yes, the link to check in for this event, great question. Let me grab it for you. It is in the Discord if you're active in the Discord, but I will drop it. Oh, look at that. such good friends in the chat, always dropping it. I'll drop it as well, so it goes to all of the platforms, not just Twitch. But like, I feel like pretty much people just watch on Twitch. But if you're not watching on Twitch, let me know in the comments so I can keep sending out the links so everybody sees them. But I deeply appreciate all of the friends who are ready with a link to drop it in there. Okay, good stuff. So somebody already guessed it. We're going to keep rolling. And someone's asking, are we going to deploy this? Yes, we are going to build. So actually, this is maybe a good, I'll respond to this question fully. Are we going to deploy this? And the answer is absolutely yes. So the thing that we are building up to is we are going to build a web app that you can go to on the internet, and it will give you a little form, and it'll say, hey, we can predict housing prices. Enter in details about your house. And we're going to get details like how big the house is in square footage, how many bathrooms and bedrooms it has, where it is in the world. We'll just be looking at the US, but we'll be looking at, state and zip code. And so you might be able to say that, like I'm currently in a townhouse that has 2 beds and 2 baths and is 1,050 square feet. And I live in this zip code and all that jazz. And I can enter that in, and then it will return a prediction of how much my house would sell for. We'll talk about a lot of caveats there. We'll get into lots of good things. But by the end, you will have deployed that web app. Because I think too often we kind of teach machine learning in a like, I'm a nerd in a college classroom and I'm tinkering away on my computer, but nobody actually gets to use it. And I think it's really cool to see you did a machine learning thing, you built a model, and now people on the internet can actually use that model. So that is where we're going to be going. Someone said 1 million, correct order of magnitude, but not exactly that amount. Cool. Oh, that actually could be fun. We could predict how much I should have spent on this house. Yeah. Okay. So somebody already guessed where we're going to head first for data. And we are going to go to a website called Kaggle. And let me just share my screen. Okay, so this is Kaggle. This is honestly not the coolest looking homepage. Is there like a... No, that's really the Kaggle homepage. Okay, well, maybe if I log out, it'll give me like a cooler looking homepage. Let's see what yeah, okay, this is like the Kaggle front page. Yes, I will drop this link in the chat. So Kaggle was actually a website that is originally built to host data science competitions, much like the one that we are going to run together as friends. But it notably has a lot of really, really cool data sets because people will run competitions saying, hey, can you make sense of this data that I have? Here's the data, and whoever does the best job of it, I'll give a Ferrari to or whatever. And so I'm going to say that if you would like to, it's not a requirement, but if you would like to, now would be a great time if you don't have a Kaggle account to sign up for a Kaggle account. We will be using Kaggle a little bit, and it's not required for this track at all. But I think it is valuable and could be fun. And I'm going to take this off of that screen so I can figure out how to sign in. I probably signed in with Google. Maybe. Oh, no, I signed in with my email. Yeah. Okay, this is actually my next question for everybody. In the chat, this is going to sound like a poor security thing to ask, but I'm curious. I have I'm very religious about, I always, if I can, sign into a website with just my actual email. I really prefer that to signing in with Google or Apple or Facebook or whatever. But drop in the chat what your preferred method of logging in. Like, are there people who are really trying to log in places with their like Apple ID? If you are, oh, that was wrong. If you are, let me know. Okay. I really signed out so I could show you the homepage, and the homepage wasn't even that cool. Okay, maybe we're signing in with Google. I actually have a good feeling about signing with Google. Okay, yeah, folks are signing in with Google. Okay, we're back in. And that looks really small. So why don't I make this bigger for us so maybe you can actually have a chance of seeing what's on my screen. Let me know in the chat, 1, if my screen size is okay, if you can see it, and 2, let me know if I'm talking too fast, because as a general rule, I am. So yeah, someone already mentioned this. We can go over to the left here, and we can look at data sets, right? And we're going to walk through like, okay, how would we go about this problem, right? I've given to you sort of the challenge statement of I want to take all this data and I want to be able to predict, given bathroom size or number of bathrooms, number of bedrooms, square footage of the house, and all these things. I want to predict the price of the house, right? So how would we go about trying to find data to solve that problem? Someone asked, are we going to work in Kaggle notebooks or back to Google Colab? For this, I am going to be doing Collab just because it doesn't require people to have a separate Kaggle account. It just requires you to have a Google account. And if you don't have a Google account, like y'all, what are you doing? This is not me being a biased person that works for Google. This is just me as a person, get a Google account, y'all. But yes, so I will be going back to Collab that we'll look at for a second. So let's go to data sets, right? And let's look at, you can see what I've been searching. Let's look at real estate data, right? And we can just go through and see what things look like. So if we click on, let's see, fun with real estate data, the first one to pop up, it has a lot of upvotes. And so we get a little report where they have some information on what they did. We could read this, but I think it'd be a lot more fun if we just went to data. And so we see we have one file that just has a bunch of prices. Oh, it looks like this is somebody's actually who competed in a competition. This is just their report. So this is actually not what we're looking for. They don't have sort of the original data here. So let's go back. Okay, we went fishing and we didn't catch anything that time. Okay, real estate data. Not fun with real estate data, just the real estate data. Boom. Okay. Okay, so this is great. We're getting a little readout of what data we can see. So this says housing values in the suburbs of Boston. I love this. People, if you find other data sets you think are cool, drop them in the chat and we'll take a look. Okay, so we have 506 instances. So that'll be 506 individual houses or homes that were sold. We have continuous attributes, including class. Okay, interesting. This is interesting. Crime per capita, crime rate by town. We have a lot of sort of contextual variables here. Like if it touches the Charles River or not, what the nitric oxide concentration is. Okay, so this is I would say this is a really rich data set. They have a lot of individual pieces of information on each of their houses they're looking at. But I think that there are two really, really big glaring shortcomings of this data set. Does anybody want to take any guesses what my issue is for using this data set for our project? Any thoughts? Yes. Okay. Someone called it out. Incredible. Yeah. So everybody's getting that it is just the suburbs of Boston. Oh, and we got the other one. Yeah. So the two things that I see when I look at this data set, first of all, really cool data, really specific things they measured here. But it is just Boston, which is a problem if we're trying to predict things for the whole nation, right? And it's also only 506 rows. And someone said too small a sample size, and that is also definitely a problem. This is interesting. Someone said too many variables, and this is actually like a kind of finer point that we will get into more, but I think it's a good observation. There are a lot of variables. One answer is if you have too many variables, you can always just drop some of them, right? But it is true that in a lot of cases, there are some models that wouldn't work as well if we only had 500 rows and we had, a bunch of columns, which it seems like there are quite a few columns here. Okay, so somebody dropped another link. Oh, am I not able to? Okay, this is going to be another grandma discovering the internet moment. I want to copy it, but I cannot copy it from this. I guess I probably should just get on Twitch to copy it. But I think we can find it. It's called Advanced Regressions Technique. House Prices Advanced Regression Technique. House Prices Advanced Regression Techniques. Cool. Okay, maybe it's this guy. And cool, they give us a little explanation. Maybe we go over to data and see what's in there. So they give us a couple different files. We'll talk about these files in a second. But our fields, okay, we have sale price. That makes sense. The building class. Okay, I'm guessing maybe that's like is it like commercial or industrial maybe? The zoning classification, lot frontage. Going through here, this seems like a little bit more like all this data really is about the house. It's not about the environment as much. They also have a lot of columns. Look at that. Wow. But now I'm actually kind of curious. One, how many rows do they have? So we might come down to train. And it looks like they have 1,400 rows. That's what it's looking like. They're probably not going to render all of them here, but it's looking like 1,400 rows. And if we go back to the overview here, and we see, again, this is for Ames, Iowa. So again, kind of similar problems. One, it's just for one city in Iowa. The other one is that 1,400 rows is more than a lot of data sets, but it's really not quite enough for us to feel like we could really build a big, robust model on it, especially with all those columns. The other thing that we haven't touched on is I'd really actually like to get a sense for when these things happened. And I'm curious if they have in this data set, they have so many columns. Did they have, I mean, surely they have like a date, right? We have like a sale date. Oh, don't bookmark, no. Date, we have year built. We have like year sold. Okay, we have year sold. I wonder if we could go find year sold. Add that and scroll all the way over. I'd love for everybody to kind of play with the Kaggle interface, just get a feel for it. It could be helpful. So it looks like our sales range from 2006 to 2010. And this is another big issue that I would, if we're looking at any data sets, that I would really want to get a sense of when did all these sales occur, right? Because if we're trying to predict houses today, stuff that happened in 2006 is not going to be very, very relevant, right? It's not going to tell us a lot about what housing prices are right now. Someone asked, wow, I wonder how many rows there would be for the whole US. That's a good question. Let's see how many houses were sold in the US in 2020. 6.5 million. Okay, so that is roughly for a year. That's a lot of houses, right? That would be how many rows there would be for the whole US for a year. 6.5 million. That's a really good question to ask. Like, how big of a population is there out there? Let's see. And how exactly do we choose the best model as per data? Yeah, so this is what we're going to be exploring. And I'm going to pull a fast one on you. I wanted to look at this data, but I actually went around and looked, and I did not find any data sets that were quite good enough for what I wanted to have us do. And so I went out and I got some data myself. I went and did some work for y'all. I won't necessarily tell you how I got this data, but we will look at some better data. Someone says, I just have a doubt, like the house price in the US differ in a state than how we'll be predicting accurately. Yeah, so this is a great question. And I think it is really, really good to do some table setting and say that the problem of trying to predict housing prices for an entire country is like unbelievably difficult, right? It's really difficult to do at all and much harder to do accurately, right? I don't know this, but so Zillow is a company that is local to me in Seattle. I have some friends that work there. I think the number of people whose full-time job, like folks with PhDs, their full-time job, there's like probably 100 of them or more that their only job is trying to predict housing prices accurately, right? So I want to just state up front, this is a monumentally difficult task. Someone said, where can I checkboard in MLH site? I'm going to guess you're looking for the Checkin Link, and I will drop that again. And you can go and check in because we love it when people check in for this. And if you haven't checked in yet, go do it. Grab that Checkin Link. Oh, okay. My friend's helping me out. Incredible. Okay, cool. So we were looking around, and none of the data. I mean, the big thing was that most of the data sets were for like one place, right? Like just Boston or just Ames, Iowa. And one of the reasons this is the case out there is because it's like a much easier problem it's a much easier problem to just solve this for one city, right? Like that's like a tractable problem that somebody can actually go for. Okay, somebody dropped another one, Kaggle Zillow Zcon. I believe I looked at this one and it just didn't give us enough granularity. So Zillow Zcon, or it gave us granularity, it just didn't give us enough detail. Yeah, so this is the and maybe I should have dig deeper. But the thing that I was seeing here is that they have lots of details on sort of like the high level, sort of over time. You can see, like state time series of things going over time. But you don't have like, here's an individual sale where this house that has 5 bathrooms and 2 bedrooms and 1,000 square feet sold for $60 million. They don't really have that on sort of the per transaction level. And it is really cool data, and I would absolutely recommend that people play with it. But yeah, that's another data set that is cool to play with. So I think I mentioned this earlier, is I did not find any data sets that I was thrilled with, and so I went and made my own. And again, I'll ask you not to tell me, or not to ask me where I got it, because I may have violated some terms of services out there. But I won't tell you whose terms of service I violated, so I'm legally not responsible. So we have our own competition for local hack day build for building a machine learning web app. And I will drop that link in there. So this is why I think it would be really great if everybody signed up for a Kaggle account. This is actually, if you win this competition, then you get to name one of my fish, right? So the way this competition is set up is that I'm going to give you a lot of data, which we will look at in a second, and then we'll look at a lot for the rest of the night. I'll give you some data, and then you will have to build a model off of that data, where I'll give you both sort of the details about the house and how much it sold for, and then I'll give you some extra data that has everything except for the price, and you will have to use the model you built to predict those prices, and then whoever gets the prices closest wins the competition, essentially. So we could kind of step through some of the pages here. So I basically went and got a big data set. And 90% of that data set is I'm giving to you sort of the entire thing. But 10% of that data set is what we call the test data set. And that you get all the details except for the price. And that's going to be something we'll talk about a little bit more next time. Evaluation, this again, we'll get into this a lot more in the coming sessions. But the metric we're going to look at, you're going to try to predict a bunch of housing prices. And those have real answers of how much that house actually sold for. And the way that we're going to calculate your, like how good you're doing, or where your place in the leaderboard is something called mean absolute error. So I'll zoom in even a little more on this. So the way to think about this, like say our data set only had 2 houses and their prices were $100 and $200. And you predicted that they should have cost $90 and $220. So the first one, you were off by 10. Your error was 10. Technically, it was negative 10, or it was positive 10. And then your second prediction is off by 20, technically negative 20. But that means on average, for your absolute error, it's 10 plus 20 divided by 2. So your mean absolute error is 15. That's kind of our metric we're looking at there. And so if you get the lowest mean absolute error, then you will win. Let's see. Yeah, pretty good summary. We're just looking at data sets. We're looking at how to find data. I'll drop this link again. So we're hosting our own Kaggle competition. Boom. Yes. Oh, hey, Hannah. It's good to see you. Yeah, I'm wearing a flower crown today because it was one of those days. It was a flower crown day. And we are looking at some housing data. So this is great. We have some data. We have some notes on the data that you can read. There's an interesting note here about non-disclosure states. So there are some states that do not make housing sales public. That I could sell a house to you and I would not have to technically report that publicly on how much I paid or how much you paid. And I am saying that for those houses in those states, you should not trust the data. That I just made something up. Okay, we'll think about how we deal with that caveat later. But it's important for y'all to know that. Okay, so now we get to our data. We have an ID in our data, totally meaningless. Stop asking about it. We have a zip code. We have a city. We have a state. We have the date it was sold. We have a number of bathrooms, the number of bedrooms, the living area in square feet, the home type, either single family, condo, townhouse, or multifamily, the home status, whether it was recently sold or sold or not sold yet, the lot area, the lot units, the address, and the price. I just flew through those. We'll look at all of those in a lot more depth in just a second. Yes, I'm recommending that everybody create a Kaggle account. You do not have to. This competition is just kind of a fun extra thing. You're not required to for the actual project we're going to build. But it could be kind of a neat way to engage. So I'd recommend it, but you do not have to. Yeah, Kaggle is a great place to find data for other things. So let's scroll down here, and if you're in here, click on train.csv, and we'll get to actually start looking at some of the data at a really high level. So we see our IDs, they're just uniformly distributed, basically. Zip codes, again, they look like numbers, but they're really just like names for categories of spaces, right? We have a city, cool, just some plain text there. We have a state. Let me scroll over here for us. We have a state, so it's like this is the two-letter abbreviation for states in the U.S. I actually will make a couple apologies. This is going to be a very state-centric sort of data project. We are going to be dealing with square feet and acres and U.S. dollars. That's where I live. That's what I know. But if you want to do this for some other country and some other real estate market, nothing would make me happier. So do not feel limited. Dates sold is interesting here. So these are timestamps. They're not super easily parsable dates, but we can see that most of them were collected around the same time. And then there was a trail off, and some of them were a little bit earlier. I'll come in. I'll just let you know. The date is not particularly meaningful here. We're mostly going to ignore that. But so then we have a number of bathrooms. Oh, okay, I'm actually going to zoom out just a little bit so I can scroll and still look at things. I hope that's still legible. We have bathrooms. That makes sense. It kind of trails off. There are a lot of places with just one or two bathrooms, and there are fewer places with more. Bedrooms. This is super interesting. Look at this and look at how this suggests that there is a house somewhere that has 15,000 bedrooms. This is like a super interesting detail, this data set that we'll think about how we're going to deal with. Living area, okay, that kind of looks pretty normal. Home type, so that's, is it a single family, is it a condo, etc. We can look at the rest of our columns. Lot area, lot unit, address, price. Apply that and scroll back on over. So we have a home status. That's either it was recently sold or the sale is still pending. Lot area. This is also interesting. You can see we have a lot that are very low, and then we have this sort of mound way out to the right. And this is actually an artifact of the fact that these numbers are only meant to be taken in the context of the units, right? And so some of these are square footage measurements, and some of them are acreage measurements. So for example, we have like 1.8 here, and that's in acres. And so that's right here. But then we have this place that's 7,000 square feet, and that's, somewhere over here because they're in different units. That's something we'll look at having to deal with as well. Then we have the address that we're mostly going to ignore, and then price. This again looks pretty normal and looks like our most expensive house in this data set is like $1.8 million. I'm gonna check back in with questions, comments. Yeah, I would love to live in a house with 15,000 bedrooms. I remember where I lived. I moved out to Seattle from Nashville, Tennessee. I lived in a suburb of Nashville, and there's this one house kind of down the street from where I lived, and it was like a giant ass like Gatsby looking house. It was just massive with this massive yard, probably like 30 acres of yard in front of it. And I genuinely think this is true, is that in the spring and summer, a guy would be out here mowing the grass. And by the time he made it to one end of the yard, he would just have to go back over to the other end of the yard and start mowing again, because it had taken him like 7 days to finish mowing. So I assume that house probably had 15,000 bedrooms in it. Yeah, Kaggle is just a website that has a lot of data and data competitions. And we have both data and data competition here. Oh, thank you for commenting on the flower crown. Yeah, no, it was one of those days I just needed a flower crown. Okay, so we are already at 45 minutes. We started a little bit late because the previous thing went over, and so we will probably go a little bit late if everybody's cool with that. But let's kind of get cracking. So we have some data. You can go ahead and download this data. There is going to be an easier way to get this data so we can start playing with it in a minute. So without further ado, let's hop into Google Colab. I think I shared this link. I definitely shared this link last time, but I will drop it again. Colab is really a fun way to... my computer is deciding to be a little slow. Is a fun way to do some data exploration in the cloud. The reason we're using it is so that we can all have sort of a similar environment, and I'm not having to help people set up their own environment. But if you have your own environment, you are more than welcome to use this. But this is, again, a great tool for playing around with and exploring data. We'll use a different set of tools when we are actually ready to sort of launch our production app. Yes, the sessions should last about 2 hours. We started maybe 10 minutes late, so we might go 10 minutes over. I might hang out later to do some Q&A if anybody has further questions. But yeah, 2 hours is kind of our target right here. Alrighty, so I will navigate to Collab. Last time I gave you a sort of a pre-filled out sheet. This time I'm going to see if we can just create a new notebook and kind of more or less figure out things for ourselves. There is a completed sheet that I will give you the link to later, but for the time being, see if you just want to follow along and code along with me. Yeah, today we've just selected our data set, and the answer is I just came up with it. But we selected our data set, and now we're going to start exploring our data and cleaning it. We're going to make heavy use of pandas, and we're going to talk a lot about sort of the trade-offs we have to make to get our data ready for machine learning. So the goal is to do all of the cleaning we need to. So next session, we can just hit the ground running and actually start training some models and actually start doing the AI, if you will. All righty. Ooh, okay. I usually don't like to talk about when things are going poorly on my computer. But if I have my mouse on my laptop or my sort of main screen, it's good. If I put my mouse onto either of my other monitors, it starts getting real slow. So that is minorly concerning. But yeah, it is doing a little beep boop right now. Yeah, it is. It is. I also, for people that came in late, last time I was not using OBS, but this time, because I wanted to show you the fish cam. Oh, okay, fish cam. Boom, fish cam. We had to have OBS loaded up. Oh no, did the fish cam freeze? That's not good. Come on, fish cam. I believe in you. I'm going to break it for a second and then see if maybe fish cam will play ball. Oh, the fish cam is back. Okay. Fish cam. Yeah, the water really did freeze. Yeah, if anybody has tips for using OBS, please give them to me because I'm still figuring it out. Okay, there is the fish cam, and now we'll just go back to my beautiful face. Because honestly, what else do you want? Oh, honestly, it actually looks like messing with the fish cam actually is making everything a little bit faster. So somehow the fish cam was breaking my whole computer. Okay, so hopefully I've given you enough time of me just fumbling around with my computer that you have been able to open up a Python notebook that looks kind of like this. If you were not here for the last session, we could do a quick run through. Basically, you can write Python in here. So you could say print hello world. And then you can click this button to run it. And it'll take a second, the first command that you run, or the first command that you ran. But then on subsequent commands, if you add another block of code and you say 1 + 1, this should run a lot faster. Boom. Okay, 2. That's your 30-second demo of Google Colab. So right off the bat, I'm going to give everybody a chunk of import statements. So we are going to say import pandas as PD. This one should be familiar from last time. We're importing pandas and we're renaming it PD. We're aliasing it as PD. We also looked at the matplotlib library. So we're going to say import matplotlib.pyplot as PLT. This will just allow us to graph some things and do some cool visualizations. Then we're going to import numpy as NP. I think we looked at this one last time. It just gives us some helpful math functionality. So numpy. Some people pronounce it numpy. I think these people are wrong, but whatever floats your boat. And then finally, we're going to import a library called Seaborn as SNS. And this one is going to give us, we're really doing it only for one cool visualization, but the visualization is cool. So we're gonna import it. Hannah says numpy. Yeah, numpy supremacy. Cool. Okay, cool. So now we're actually going to get in our data. So import and run that. So if you remember last time, we can run pandas.read_CSV. And then if we have a CSV handy, we can actually read in that data. Google Colab is a little bit funky. Normally, I would just literally have, like my data.csv, and that would be fine. It's kind of hard to get files into Google Colab, but luckily, you can actually just put a URL, and if your data is hosted on the interwebs, then you can just download it directly. And that's why I have hosted this data on my GitHub, and I will drop that link for you now. Boom. Yeah, someone's asking what Seaborn is. It basically, so matplotlib is just for sort of basic graphing functionality. Seaborn gives us kind of a lot of cool little stylistic things. We're not going to use it heavily, so I'm not going to spend too much time on it, but it's graphs, basically. That's what it is. And so I just dropped the sort of the raw link there that will give us our training data set. And maybe we call this train, and we import it, and we say train.head. Remember head, previously we did .head, and it gives us just the first little snippet of our, basically of our pandas spreadsheet, right? So we can run that, and boom. Okay, so there should be no surprises here, because earlier we were looking at Kaggle, not that one, not you. Yes, this one. We're looking at Kaggle, and this is the same data that we have in train.csv right here, right? In fact, it should even be ordered the same. Caddo Springs Drive. Look at that, Caddo Springs Drive. I'll be honest, I was very concerned for a second that it was not going to be the right thing, because this was like 11 p.m. last night. I was like, dang, I gotta launch this competition. But we did it. We got it correct. Someone said, do we need to put index call thingy in read CSV? Oh yeah, that's actually fair. If you want to say, I think it's index call and then say ID. This just means that we preserve our ID column as our index. It's not, I mean, if you don't want to, that's not needed per se, but it keeps things a little bit cleaner. Yeah, no, that's a great tip actually. Thank you for that one. Someone asked if I could share the data link once more, and I absolutely will. Oh, there you go. And so we can, if we want to, we could just look at this. Also, let me know about screen size. It feels actually a little bit claustrophobic to me. So let me know if this is too small. If this is too small, I can go one tick back up. But if this works for folks, then this would probably be ideal for me. Okay, this is fine. If it's not fine for you, let me know, and and we'll adjust. Okay. Cool. Oh, it looks like Fishcam is freezing again. Yeah, Fishcam is frozen. Dang. Okay. Well, I'm actually just gonna break Fishcam now because it's upsetting me, and go back to talking head mode. Y'all are very kind to just hang out while I attempt to learn how to use OBS. Yeah, that's wild. Okay. Well, more things for me to learn about. Okay, someone says please increase the size. If somebody needs it, then we can do that. This still works for me more or less. So that will be what we do. So we could kind of go through here and look at things, but we're now going to start using other tools to try to understand what's going on in our data. So one thing that we're going to do right off the bat is we're going to look at what columns we have. So remember, if you have the name of the CSV or the name of the data frame, and you say columns, you can hit return there, and you just get a list of the columns, right? These are the same columns that we saw before, but it is still helpful to have that list. And one of the reasons that it is helpful for us to have that list is because something else we touched on last time, we can loop over it, right? This is list-like, or it's list-like enough. And so we will say for column in train.columns, and then we'll hit that that colon, which lets us go into our loop. And now we can do whatever we want for each column. So one thing we'll do is let's just print the column name. And then what we're going to do next is we're going to print out, so get our little print statement. And we're going to say train, then our square brackets, and say column. So remember, square brackets and then the column name in the middle means we're getting just that column. In fact, maybe it's helpful just for a refresher before we get in here. If we say train and then we put in there a string that says state, we get our whole list of just all of our states. And we still have our IDs on the left here, but we just get the states, right? So that's a way of pulling one column individually. We'll dump that. So column will take a turn being each of these individual columns. And then we will print, not the column itself, but we'll use this super handy dandy method called value counts. I believe that we used this last time. And what this does is it basically will show us all of our most common values for all of our individual columns. The last thing we're going to do is we're going to chain onto the end of this a method that we did not talk about before called n_largest. We'll do some curly braces there. And so this will basically just let us, we can say 5. So we'll look at the 5 most common values in each column. And this will be kind of another helpful way to explore what's going on in our data. What do we need to be paying attention to? So we'll run this, and this will produce a lot of output that we'll have to scroll through. Actually, I'm going to also add in another print statement just to give us a new line, just so it's broken up a little bit. That's a little bit better. And booyah. Okay, so we see zip codes. One thing that we did not talk about yet that actually is probably pretty important to do before we get here, and I know I'm jumping all over the place. Someone asked if we are going to get this notebook in the Discord after, and yes, I will definitely. I'll drop it in the chat. I'll drop the link to the notebook in the chat, and I will also drop it in Discord. And I will attempt to slow down, but I'm very caffeinated and I'm excited. This stuff is cool, but I will attempt to go as slowly and speak as clearly as I possibly can. Okay, so one thing that we're going to want to do right off the bat is to just check how many rows do we have, how much data is there, how many houses are we looking at. So let's run that. And we have just over, or a decent bit over, 23,000 rows. We'll talk a little bit more next time about how much data do you need to make a machine learning model work. But I think a lot of people would say for something like this is really about the bare minimum. You really, for a lot of projects, want at least a couple thousand records. That's highly variable based on what you're trying to do. If you're trying to predict something very simple, then maybe you only need, a couple hundred. If you're trying to do, image recognition, maybe you need several million. But for a project like this, I feel decently comfortable with 23,000 in our length. So now that we know that length, we can actually come down and look at our values and make a little bit better sense of them. Okay, 103 of that one zip code. So that's 103 houses in the same zip code is our most common zip code. But that's not even, that's not even 1% of all of our records. So zip codes are really disperse, is something that we take out of that. Again, cities. Okay, we have a lot of houses from Anchorage. That's interesting. And a lot from Louisville. But again, that's just over 0.1%. So not a ton of a single state. We have a lot of houses from Connecticut. Now we're looking at states. And 938. That is now actually, I don't know exactly what that is, but that's I will say more than 1%. That's maybe actually like around like 3 or 4% of our total data. So we have a lot of Connecticut houses. Dates, I'll say that we are basically going to ignore date. Don't worry about it. Bathrooms. Okay, so this also is like now we're getting into sort of standard variables where we have a bunch of integers that vary, right? And so a lot of houses have 2 bathrooms. My house has 2 bathrooms, so I'm included in this number. And then the next most common number of bathrooms to have is 3. That kind of makes sense. And then 1, and then we go to 4, 5, 6, 7, whatever. So that's kind of an interesting read to get. Bedrooms, kind of a similar pattern. It's very uncommon to have a single bedroom, at least in this data set. It's very common to have 3 or 4 or 2. Some other folks are saying they still want it a little more zoomed in. I will try one more tick zoomed in. Let me know if this is better for you. This starts to feel a little bit cramped for me, but we'll see if we can make this work. I definitely want it to be legible for everybody. Someone said in large projects like housing prediction is kind of time sensitive, so data keeps on getting added. Yeah, this is a great insight. And so I'll say one of the things that I did for this data set is I wanted to get really recent data. And that is one of the reasons that I made my own data set as opposed to finding one of those other public ones. So this project is time sensitive. And we might talk about how you would get more data to keep this model fresh in sort of future streams. Someone said, could you tell me how did you get rid of that attribute error when I put code in different cells? I'm not sure what the attribute error you're talking about is. Maybe if you can drop some more context. We can definitely kind of scroll through. Also, I'll say if you do start hitting some errors, feel free to maybe actually halfway. I'll drop my actual sheet, but you'll get everything at the end and hopefully sooner as well. Cool deal. So we're looking at all of our individual columns. And yeah, if you want to share more of the code that gave you your error, that would be great. And we can, as a community, we can help you debug it. It'll be awesome. Okay, so we looked at bedrooms. We looked at living area. Living area is interesting because it's not like you can't really have half of a bedroom. It's really, an integer. Whereas living area is more continuous, right? You can have half of a square foot or 3/4 of a square foot or whatever. And so I think that is interesting that we still do have, there are 96 houses that have 960 square feet in them. But yeah, it's interesting to dive into. Okay, home type. This is now we're getting some other interesting stuff here, where this is what we would call sort of a classic categorical variable. A single family house is not like 2 times a condo, right? A single family house is a different kind of thing than a condo. If you're not familiar, and these might be kind of specific terms that we use in the States, a single family home is like you have a house and it's on land that you own. So you have a yard, all of those things. You don't share any walls with anyone. This is kind of like classic house, right? Condo, that is where it's basically an apartment that you own, right? So it's I used to live in an apartment, and if I had purchased that apartment, then it would have been a condo. townhouses, that's what I live in now, where I actually have a little bit of a yard in the front and a little bit of a yard in the back, and nobody lives above me or below me, but I do share walls on the side. And then multifamily, that's simply where we have like a duplex or a quadplex, where you have 4 different sort of mini apartments built into the same building. So we have a lot of single family homes here. We also see that we have recently sold is most of them, but pending there are a few. And I'm actually going to say that we actually want to throw out all of our pending records, because these might never actually happen, right? Someone's saying, hey, I want to buy this house, but nobody has actually bought this house yet. So the first thing we're going to do is actually just take out all of our pending records. Someone's saying it's the same error that I got at the beginning. I honestly, head empty, I don't remember what error I got at the beginning. Okay. So then we'll speed through the last couple here so we can kind of get on and actually start dealing with our data. We have lot area. So that's interesting. A whole ton of places don't have any land. And this actually makes sense, right? We talked about condos. If you live in a condo, you don't have a yard, right? There isn't like a physical lot that you own. And so you would have 0 in that cell. Then we have, a couple places that happen to have that much land. Doesn't really mean that much to me. This is, again, important, is that this number up here, and we'll look at this a little bit more, is that some of these are in square feet and some of these are in acres. And that's like a big difference that we have to make sense of and distinguish between. Oh yeah, you totally can just share the link to your Collab if you want us to kind of take a look at it. Address, we'll be ignoring address, so we can drop that. And then price. Interestingly, a lot of houses sell for $250,000. I don't know what you want to do with that. Let's see. How can you have 4 of the same address? Oh, that's an excellent point. That means we just have some duplicates in our data set, which is something that I thought about a long time ago, and it was on my to-do list to filter out duplicates. But very clearly, I did not. So we will take a look at maybe filtering out duplicates. Maybe that should be the first thing that we do. Yeah, I'll make a note of that. Cool. Oh, that's an interesting point. Unit number could be different. That's totally possible. I think it probably is. They're actually just literally duplicate lines. So I'm dealing with duplicates, but we'll charge ahead for now. But excellent observation. That is something that I should have caught earlier. Good deal. So one of the first things that we said is that we want to only look at things that have been recently sold, not offers that are still pending. And so if we think back to how we filter out things, I like the idea that maybe people from the same house reported the same thing. Like 4 roommates were like, all right, we're buying a house. And they're all like, yeah, I bought a house. And then their 3 roommates were like, yeah, I bought a house. I'm going to go with that. It's probably not true, but I like that narrative. Okay, so if we remember back to our last session, the way that we filter out something is by putting our condition inside square brackets. So we have our train, and what we're going to say is train home status. And I mean, we can just look at what's inside there, right? Okay, recently sold, pending, recently sold, etc. We can say equals recently sold. And so now we have a Boolean list, right, where it says true where it's recently sold, false where it's not been recently sold. And so then what we're going to do is we're going to place all of this between square brackets for train. And this will effectively, if we run this, it will filter out everything that wasn't recently sold. So you remember earlier we had some of these that said pending. Now all of them just say recently sold. So that is great. One note that we threw out from last time is that when you're doing filtering like this, you always want to run .copy at the end so that we're not looking at a view of our old thing. We're looking at a new copy of the data. That's important for other reasons. But so we could maybe call this train only sold. It's really important to kind of have clear names for your data frames as you're filtering and playing with them. So we'll call this train only sold. And underneath that, we could run dot head. Uh-oh, I did it silly. Okay, so we can see just the recently sold things there. We also now we can drop some of our columns, right? I think we looked at dropping columns. So we'll say train only sold, and we will say drop, and then we will throw a list in there. So we just did away with home status. So we can say home status, we'll drop that. We also talked about dropping address. We're also talking about dropping the time. Oh yeah, I'll zoom back up here. So we basically, and in fact, I'll just drop this. If there are any lines of code that you're like, can I just have that? I'll plop it in there. Yeah, someone mentioned that they used to name their data frames ADF, BDF, CDF. Yeah, it's taxing. And I think one good thing to point out here is that this is because we're exploring, we're playing. We might not do things sort of the most efficient way because we're just getting a sense of our data. Okay, incredible. So now we're filtering out columns we don't want anymore. I mentioned that we're not going to be using address. I was contemplating whether or not I should mention this. Technically, you could cheat and you could just go look up all of these addresses. It would take a long time unless you wrote a script to do it. But that is against the rules and it is not in the spirit of our competition. So don't do it, okay? And I will actually make you turn in, if you win, I'll make you turn in the code that you used if you want your prize of naming a fish. So don't cheat. Someone asked, can you help me understand the difference between copy and deep copy? The quick difference is that copy is not recursive and deep copy is. So there are like weird cases where you could have basically like functionally you could have a data frame inside of a data frame, or you could have a dictionary inside a data frame. Things that kind of have their own spaces in memory that are kind of holding one another. And when you do a copy, it creates a copy in memory of just the top level. So for us, we only have one level here. Basically, it's all one data frame. But if we had sort of layers of things that had their own space in memory, then we would want to use deep copy to copy all of those things. It could get a little bit hairy, but in our time here, we're basically just going to be doing we're just going to be using dot copy. But yeah, deep copy is a good thing for folks to be aware of. And in some cases, it's needed. Okay, so we'll drop address. I also said date sold. All of these are fairly fresh, so we'll drop date sold as well. And then we will say, we'll just assign this, or we'll say in place. This is a super helpful function that a lot of these have. You can say in place equals true. And so now, instead of just returning what this would look like, it'll actually do the transformation we're asking for. And then we can just plop this down and say .head to get a look at it again. Oh, I did an ouchie. Oh, okay, this is actually a great thing. This is an error that I come up against all the time. We could spend a lot of time talking about axes in pandas, but the upshot here is that when you're dealing with columns, when you're trying to filter or drop columns, this is what we think of as the number one axis. Yes, this axis equals 1. Basically, what it was trying to do is its first thought was, oh, you want to drop the row named home status, and you want to drop the address or the row named address, and we don't have a row named home status or a row named address. And so we just say axis 1, we're talking about columns here. That's one that I actually, one that I hit more often than I would like to admit. Okay, so we're looking at a pretty clean DF now, right? Like it can basically fit on one screen, which is awesome. I'm actually going to run this again to refresh train only sold, and one more that I want to get rid of. Oh wait, no, I don't want to get rid of anything else yet. No, okay, yeah, this is good. So we'll run that, and we will charge ahead. Okay, so one thing that we are going to look at is what variables are numerical. This is looking ahead a little bit, but basically we have a huge world of machine learning algorithms that we can use, but almost all of them depend on all the data that you give it being numbers, right? So everything that you look at that is not a number is going to be really hard to feed to a machine learning algorithm. And so a lot of our process going forward is going to be figuring out what is the right way to turn these things that are not numbers into numbers so we can use them for our machine learning algorithm. And there are a couple of things we'll walk through. First of all, price is a number. That's what we're trying to predict. Lot area is a number, so that's good. Home type, we're going to have to deal with this. This is what we call a categorical variable. Living area, that's a good, nice scalar. We have some integers, bedrooms and bathrooms. State, again, that is categorical, right? You can't have like half of Texas. Someone asked, where can I get this data set? No worries, you are totally fine. I will scroll back up. This is the URL to the data set. And thank you for joining us. I'm just delighted to have people show up. It is thrilling. And then the other thing that I'll throw out is if you're just joining, we're going to be, as a group, as a family, we're going to be running our own little competition. We're not really diving into the competition too much yet, but if you want to go sign up on Kaggle, I would totally recommend that you do. It'll be fun. Okay, so there's some data. Boom, boom, boom. Great. So home type, that's categorical. These are all numerical. That's great. State is a category. They love ML, and it's their pleasure to be here. I love ML, and it's a pleasure for me to be here. This is great. State is categorical. City is categorical. And then zip code. This is like your pop question. What is zip code a number or is it a category? Everybody, do your best guesses in chat. Someone was asking what the Kaggle competition is about. We'll be doing more on the Kaggle competition later. But basically, everybody's going to build their own model and try to predict housing prices, and whoever gets the best accuracy or their least error, sort of the best score, wins. And they don't win any prize except for getting to name a fish. But we'll do that a little bit later. Yes. Okay. So this is great. This is like obviously on purpose a trick question. This is like sort of a classical trick question in early stats classes. Yeah. And so technically, if you said technically it is a number, like that is technically true. But how do we want to deal with it? And this is sort of like the best question to ask yourself to tell yourself if something is numerical or if it is categorical. If you multiply it by 2, is the thing that you get twice the thing that you started out with, right? So for example, if I have 3 bedrooms and I multiply that by 2 and I have 6 bathrooms, that actually is twice the number of bathrooms, right? If I take zip code 76247 and I multiply that by 2, this is not actually a zip code, right? It's like now a total nonsense piece of data. And so that is the way, at least that's the way that I think about it is if you multiply something by 2 or do any arithmetic to it, would that actually make sense? And for some of these, it makes sense. Zip code is sort of, as far as we're concerned, a categorical variable. Someone's asking how they can start contributing to MLH. I would say, first of all, being here and participating in the community is a great way. That is a question that is a little bit off topic. And so if you want to stick around to the end, that's one that we can talk more about at the end. Or you can ask Hannah, because Hannah is great about getting involved. Incredible. Okay, so there's a similar thing in India called PIN code, but it's not called zip code. Yeah, zip code, as far as I know, is a US construct. Postal code might be the easier way we say this. So someone's mentioning that some houses have lot area as 0. And this is something that we did talk about, is that, that this actually makes a lot of sense, because if you are in a condo, you actually don't have a lot, right? You're like up in the sky, right? There's no land touching you. And that is the reason that you see a lot of zeros. The things that are condos or apartments or even townhouses, sometimes they won't own the land that they're on. And that's why you might see a lot of 0. Hannah says, we'll drop links here soon. Oh, incredible. I thought you were saying, will drop links here soon, like as a command. And I was like, Hannah, I'm trying my best. But you were saying that you will drop links here soon. Incredible. Let's see. Someone says, is living area in square feet? Some of them are also in acres. No, so all the living area is in square feet. This is a great question. There's a technical detail about that written in the documentation in the competition somewhere, but it's a fair question, and no. Lot area is the only one that will vary. And that actually might be a good thing for us to deal with next. Let's see, what do we want to look at next? Actually, we're going to do some univariate exploration now. So let's actually make a list of all our numerical variables, or all our numerical columns. Say numerical columns, and we will just say bathrooms, bedrooms, living area, and lot area. And I guess we can throw a price in there as well. And so now what we can do is let's actually do some plotting, right? So let's say 4 column in numerical columns. And let's say PLT title column. So this will just give a column to our graph. We'll say PLT hist, so we'll do a histogram of all of these values. And we will say train only sold, and then we'll index into our column. And then we'll say plt.show. If you have questions about this snippet of code, there's a decent bit going on here. But so we're looping through all of these columns, and we're saying for each of those columns, make a graph that has the title of the column, and then does a histogram of all the values. If you're not familiar with what a histogram is, we can maybe actually talk about that briefly. This is not a stats class, but maybe we can cover it. So the way to think about histograms is basically they just count frequencies, right? And so this line right here, it doesn't line up perfectly, but say that goes to 2.5. And so this is basically saying that 14,000 of our houses have less than between 0 and 2.5 bathrooms, right? And like say this went from 2.5 to 5 or whatever, and that would say that we have about 6,000 houses that have that many, like in that range. So we're kind of counting how common are different ranges of variables. So bathrooms kind of make sense. It seems kind of weird that something is out here with 17.5 bathrooms or whatever. Bedrooms. Okay, this is the one that we were like, what's going on here when we saw it earlier, right? So we have a lot that have less than 2,000 bedrooms, right? And like, yeah, no duh. But then it goes all the way out to 14,000, suggesting that there is some record that has like 14,000 beds or close to it, making our graph look this way. That is classically what we'd think of as an outlier. Living area. This actually looks pretty normal, right? Like I believe that our biggest house has maybe 10,000 square feet, but most of our houses have about 2,000 square feet. Or a little bit less than that. I'm currently in this house 1,050 square feet. Cool. Lot area. So this is the one that we talked about earlier that we'll dive into, but this is kind of the good example of we have 2 different distributions here, right? We have this is all our data that's in acres, and this is all our data that's in square foot. So we should deal with that. Probably that'll be our next thing. And then price actually looks pretty normal, right? So one thing we want to deal with later is getting rid of outliers. We will talk about outliers and like philosophy around them. But before we get there, what if we just dealt with this graph right here? We tried to clean up lot area, right? So if we go back just to grab what is our data frame called? Train only sold. And let's head that again so we can see it. Cool. So we have lot area and we have lot unit. And basically what we want to do here is that if lot unit says acres, we want to multiply this, or we want to convert it into square feet. So let's say, how many square feet in an acre? And the answer is 43,560. That's a lot of square feet in an acre. Cool. GTK. So we'll just say square feet in acre. And now we're going to write a function. So we looked at functions a little bit earlier, and this is why, is because one thing we do a lot is we write functions that accept a whole row as their argument. So we're going to say define a function called convert lot area, and it's going to accept in a row. And now we can do whatever we want in this row, but we just want to return a converted lot area. So for this, we can use just a simple if statement, right? We can see if row, and then we can index normally and say lot unit. If the lot unit is acres, and we want to actually return the lot area multiplied by square feet in an acre, right? So think about this, that if we're looking at acres, in order to convert everything to square feet, we have to multiply the number of acres by the number of square feet in 1 acre, and that'll give us square feet. Otherwise, we know that we're then in lot area, and we can just return, or sorry, we know we're in square feet already, and we can just return lot area. If you're like, wait, Will, couldn't there be other lot units? And the answer is no, there couldn't be, because we looked at it and we saw lot unit, square feet, acres, the only two possibilities. Oh, I'm glad that it's been exciting, and thank you so much for being here. Also, y'all have been here long enough. I should probably drop the secret word. So if you want to be in the raffle to name one of my fish that are not present on cam yet because it was crashing my computer, dang you OBS, then what you should do, I will drop the link for the feedback form. Tell me that you're in this session, which is, I think, choosing and cleaning your data. And make sure in your message, let's see, what's a good word to include? Include the word acre, which I know is like an awful word to pick as the secret word because it's kind of funky spelled. But include the word acre in your message, and that's how I'll know that you were paying attention and you deserve the right to name one of my fish. Okay. So just go in there, drop the word acre in there. And hit submit. Also, if you have feedback, if you want to say I did a good job or a bad job, or you have other thoughts or questions, please do. Incredible. Okay, so we have now defined this function that takes in an entire row and then returns the converted lot area. So the question is now, how do we use this? And the answer is we use a method called the apply method. So we will take our original data frame, is it train only sold, and we will say dot apply, and we will just plop in there our function that we want to apply, and then we're going to need axis equals 1 again. Hit run. Cool. So now we have a bunch of converted values, but we actually want to store these somewhere, right? So we can actually create our own column like we did in the last session. And we could maybe name this, actually, maybe we just overwrite it. Maybe we just say lot area because we don't need the old lot area anymore. Hit return, and maybe we say head to see what that looks like. Great. Okay, so now we see that even this one in acres, this is now converted, which also means we can drop this column because this column doesn't mean anything to us anymore, right? So we will say drop, and we will say lot unit, and we can say in place equals true, and we can say axis equals 1. And then we can print that out again to make sure it looks right. Awesome. We now have a converted lot area that we can trust, and we got rid of the units. Okay. Incredible. Also, I'm looking at the time, and it is waning fast. And so I know one person said that I was going a little bit too fast, and I apologize, but I am probably going to keep this speed or maybe pick up the pace. The big thing that I will say is that I will stick around to the end, and any questions you have, I will answer. I will also drop the code for you. So if you want to go back and review all of this later, you will have all of this code and no need to worry about that. So if you just want to let it wash over you and then you can take a second pass later, I think that's totally cool. or if you're following along and you have any problems, let me know in the chat for sure. And also, as Hannah mentioned, all the recordings are available on Twitch and YouTube. Okay, someone mentioned, I tried this for automatically add numerical columns. Numerical columns is column and have to pop zip code manually, but that's all just 1 out of 6. Oh yeah, okay, so this is actually a good thing to throw out. So I think this is actually very clever, and this is something that I have done before. I will highlight that there are some things that you can do in a much smarter way, and I am doing them in usually kind of the simplest way that I can think, purely for the purposes of having them be easy to understand. But this thing that you are suggesting, I think, is a great idea, and other people that want to see that, if you want to steal that as an idea, I would totally recommend it. I think that's a little pro tip there for sure. Can't type as fast as Will. Okay, I think this is fair. I'll drop the link right now. It is also actually on GitHub. So if you want to just follow along and have the code and not have to type it out yourself, then I will right now. You can go to File. You can say Open Notebook. Go to GitHub. And if you go to that same GitHub link that I dropped earlier, which I will grab again. If you take this GitHub link and you plop it right in there, hit return, you should see part 2. And if you click on that, you will have most of the content that I'm going through pretty much how I'm doing it right now. I might be doing things a little bit different, but for the most part, this is capturing sort of the same essence there. So that's your chance to kind of bail out and just follow along. I know that I'm going pretty fast and typing fast, so if that's helpful, then please take advantage of that for sure. Incredible. Okay, so the next thing that we want to do is to remove some outliers. Now, we mentioned earlier that bedrooms right here, there's a crazy outlier. Basically, that just means that there is one data point, or maybe more than one, that is so far away from what most of our data looks like that it's going to be really hard to deal with. It's going to cause lots of problems. And some people would say, hey, you should try to predict your outliers as well. Like you should really want to look at those. And I think that if you have an insane amount of data, then it is great to try to deal with your outliers. But I think that we are working with, it's funny to say that 20,000 rows is not that much data. But in the grand scheme of things, where there are 6 million houses sold every year, it's really not that much data. And so I am actually just going to say that we should get rid of all of our outliers. It's going to make a lot of our analysis a lot easier. So if you remember back to stats class, oh yeah, because we already dropped it. Oh great. Let's back up. Train only sold. Wait, that one work? Sometimes if you mess things up, you should just come back to the very top and then just like crank through them and hit enter a lot. There's also the button up here that says, I think it's under runtime, where you can say run all. That also works. Sweet. But you can also just hit return a lot of times because that's fun. Let's see. Okay, someone said for bedroom outlier, is that what people call skewed data? Yeah, this is actually a great term to throw out. So skewed data is when your data, roughly speaking, is not symmetrical, right? And so, I mean, this one we can get rid of anyway. But so bathrooms in this case is a little bit skewed because it has kind of its peak right here, and then it kind of trails off to the right, right? And so we actually say that it has a little bit of a right skew. Bedrooms has like a massive right skew because it goes way out there. Living area is a lot closer to being symmetrical, but it also has a little bit of a right skew there. Lot area, that's just ridiculous, so we won't talk about that. And then price, again, this is definitely less skewed, but it has a little bit of a right skew because it kind of trails off to the right. And in general, if we could make all of our data normal distributions, like that would be great. But as it happens, a lot of data you see out in the world is skewed to one side or the other. Yeah, no, that's a great term to throw out. And our outlier in this case makes this a very skewed data set for bedrooms. Excellent point. Okay, so We ran that. We ran that. And then we dropped lot unit. Incredible. So now we're going to knock out our outliers. And so if you remember back in your stats class, or if you if I just tell you this, that technically we consider something to be an outlier if it is 3 times the standard deviation, or if it's more than 3 standard deviations away from the mean. So what does this mean? Well, let's take a look. Let's look at our column for bedrooms, because that's the one that was really skewed. And let's say dot mean. So this will give us the mean of bedrooms. So on average, we have 3.8 bedrooms. That's like a pretty normal number of bedrooms, right? But let's also look at what our standard deviation is. So this basically says how spread out our bedrooms. 99. Okay, so this is really abnormal. It's really weird to have that big of a standard deviation when most of our data is so small. And that's because we have that crazy outlier. But so basically what we're saying is that, okay, if our mean is 3 and our standard deviation is 99, then, well, what is, let's see, bedroom mean and bedroom standard deviation. So we're saying that if your bedroom standard deviation, actually, let's say bedroom standard deviation times 3, and we'll say times 3 over here. And so we are saying that, oh, that's not what I wanted. Bad code. So we're saying that if you have more than 298 bedrooms more than the average, which is like 3.8, or 298 bathrooms less than the average, which is again 3.8, then you are considered an outlier, right? So this gives a wide range. Most of our data will still be considered. So we will say, and so the way that we'll actually do this filtering, hopefully will make sense. We will just say train, oh, pardon me, I didn't want that. We'll say train only sold where train only sold bedrooms. This is our actual variable where it minus the mean, so the difference between it and the mean, then we'll wrap this in some absolute values. So ABS gives us the absolute value, so we don't deal with negatives and positives, they're all positive. If that difference is less than 3 times our standard deviation, then we are officially saying this is not an outlier. Okay, let's see. We say, why is skew data not good? Skew data isn't good because it often doesn't convey our data correctly or doesn't show the true correct story, especially when we were working with it. Yeah, I think that's a really good way of putting it. One thing that I'll throw out is that 2 different values we use to describe our data are often the mean and the median. And the median is if you line up all of your different data, which value is like literally in the middle. And the mean is averaging all your data together. And if your distribution is normal, then those basically look the same, right? If you have sort of a normal symmetrical distribution, then your median and your mean should be almost the same number. When you have skew, it basically pulls your mean out towards the tail, but your median stays put. And so it makes things just a little bit trickier to deal with. Someone asked, explaining the outlier logic again. Yeah, I'm actually kind of curious if we could maybe pull up a graphic for outliers. Outlier graphic. Okay, I'm not instantly seeing any great. Actually, this one's okay. Let's see if I can open this in a new tab and actually show you. Okay, so this is maybe a visual explanation of an outlier. I don't know what this data is, but we have mostly sort of a normal distribution. And basically, well, okay, I don't love this anymore now that I'm looking at it. But basically, most of this data is like close enough to the mean that it really kind of looks similar. But then this thing way over here is so far away from the mean that it is likely to be a special case. So like one thing that we actually often think about, especially when we're looking at states, is we have 50 states, but we also have the District of Columbia. And the District of Columbia is basically a like a very tiny landmass that is all one giant city, right? Washington D.C. is like one giant city, and so if you look at things like population density, the average population density will be, I'm curious what the average population density is in the U.S. 90 people per square mile. And then if you look at population density of DC, 11,000 people per square mile in Washington, D.C., right? The normal is 90, and that's 11,000. And so if you're looking at density, then maybe you should not compare normal states with Washington, D.C., right? That's just like one example that I think of. But so basically the idea is that if it is so far away from your mean that it doesn't really reflect the rest of your data, then maybe it will be hard to deal with them all together. And so we're just going to filter them out. So we can run this and we can actually say train no outliers. Do our dot copy there. And so now actually what I want to see, now that we have filtered out all of our outliers for bedrooms, if we take our old data set and we just graph that with the histogram, so plt.hist of that, and then we take our new one with no outliers and we say plt.hist, but we also look at bedrooms, and we can say plt.show and then plt.show again. And so we can see we removed an outlier, and now our max value, instead of being 14,000, it's only 30, right? And it kind of looks like our graph doesn't change that much. But like if you told me, hey, yeah, some houses have 30 bedrooms, I'd be like, that's a lot of bedrooms, but I believe you. When you're telling me that one house has 14,000 bedrooms, I'm like, straight up, I think that you're lying to me, right? So we have now transformed our data into something that at least we don't think that we're being lied to here. Let's see. Basically, out of 100 people, if 90 people live within 10 meters and the rest 10 people like greater than 100 kilometers, yeah. How did we filter the outliers in our code? Yes, this is a great question, and I'll run back over this again. So the mean, we know what the mean is, right? And our mean, if we just look at the mean is 3.8, right? So on average, you have 3.8 bedrooms. Standard deviation is a little bit trickier. So let's just look just at standard deviation again. Standard deviation generally is, on average, how far away from your data from your mean are your data points. And so I'm trying to think of like a good example of something that has a low standard deviation and a high standard deviation. So maybe we think about like amount of money in your bank account and age, right? So I'll just throw out some numbers. I think that probably like the average age in the world is like probably like, or actually I won't make up numbers. Let's say average age in the US. 38 years. Okay, I was gonna say 40 years. That was gonna be my guess. So I could have guessed. And the standard deviation, you have some people that are 1 year old and some people that are 100 and a lot of people that are, 38 years. Your standard deviation, it might be like 15 years or something, right? Because these numbers are like all just literally pretty close together. But if we looked at like average income, right? So what is average income in the US? 31,000, right? So some people are making 31,000, but the variation, just the absolute number, is going to be way wider, right? If I said the standard deviation was 15, because the standard deviation of ages might be 15, right? That on average your people are 15 years different from the mean. But if I said, oh, the average person is $15 away from making 31,000, that would be ridiculous, right? The dispersion is probably a lot greater just because the magnitude of numbers we're working with is bigger. So that standard deviation is, on average, how far away from the average are you? which I know we're getting on like averages of averages, and it gets a little bit tricky. But that's sort of my best way of describing it. And so what this allows us to do is to just kind of identify which data points are just so weird that maybe they're not helpful for us. Let me know if that description kind of helped. This is again kind of a stats thing, but it's a little bit tricky. Someone asked, would you manually filter outliers often, or can you use standardization techniques to do this for you in the modeling process, or is that something totally different? Yeah, this is a great question, and I think this is where we get into that data science and machine learning is both a science and an art, right? That we have a lot of things that we've studied. There also are some things where it's going to depend on the scenario, right? I think in this scenario specifically, because that single number was so far out. I mean, so one thing that I'll throw out is that later we're going to test our model and we're going to look at average error, right? Like on average, how far did we get off from it, right? And so like, let's just say that our model was for every bedroom you have, you get, you add $1,000 to the price. Well, if they have 14,000 beds, that creates a massive number. And that's now this huge amount of error. And so we'll end up sort of accommodating that one data point and making all of our other predictions worse, right? And so that's the reason that in this scenario, I think it's probably a good idea just to get rid of that one data point. But there certainly are other scenarios where you might want to keep outliers. And you mentioned, I think, normalization or standardization. And that's a set of techniques that we probably will talk about next time. But yeah, and in this case, I think it's good to take out that outlier. But in other cases, we might not. Great question. So now I actually want to come and let's scroll back up to our this logic. And let's just look at our variables again, because we've edited a couple of them. I guess we did that one right there. But let's say train no outliers is our data frame. So bedroom is looking better. Bathroom is looking okay. Living area looking okay. Lot area. This actually now is looking a lot better to me. A lot of places don't have that much of a yard. And then it kind of trails up. And then price still looks the same. Right on. Okay, so we have done a little bit of cleaning, and at this point, I want to start looking at what we will call a bivariate analysis. So we're really looking at one variable at a time, so we call it univariate. But when we start looking at how variables interact, we call that bivariate, because it's two, bi means two, then we're looking at two variables at a time. And this is actually the reason that we imported Seaborn, and this is the only reason, is because there is a really cool visualization you can do. So there is a thing called a correlation matrix that you can get by just typing .corr, C-O-R-R. You can run. And this basically down here shows you each variable, how correlated is it with another variable, right? So one is like you're literally the same variable. And so we see along the diagonal here, zip code and zip code, they're perfectly correlated because they're the same thing, right? But then you can look at other things. Like, for example, your zip code doesn't really have any bearing on how many bathrooms you have, right? And it shouldn't, right? It would be silly if zip code determined how many bathrooms you had. But something else that we can look at is the number of bedrooms and living area. So bedrooms in this column and living area in the row, 0.62. So it's not one, it's not a perfect correlation, but those things actually are pretty related, right? But this is a lot of numbers and it's a little bit hard to see exactly what's going on. And so I really like, you can feed this to a function called sns.heatmap. And boom, look at that puppy. Isn't that just gorgeous? Don't you just love looking at that thing? So we see things that are highly correlated are going to be really light, and things that are not correlated are going to be dark over here. So we see what we were looking at earlier, that living area and bedrooms and bathrooms are kind of correlated. We can also see down here the things that are correlated with price. And this is what we ultimately really care about, right? So zip code, again, we talked about it. It's treating it like a number, but it's really a categorical variable. But bathrooms, pretty correlated with price. Living area, pretty correlated with price. Bedrooms, actually less correlated with price, which is interesting. Lot area, not that correlated with price, interestingly. I'm curious why anybody thinks lot area might not be correlated with price, or why it's less correlated with price. Does anybody have any ideas there? Yeah, okay. A lot of great convo in the chat about getting rid of outliers. You're really just saying what data point is so different from the rest of them, and we'll get rid of that one. And we're using math to do that. Yes, this is why we use Seaborn. Someone said neighborhood also matters. Yeah, that's fair. The lot size, like if you have a big yard in a bad neighborhood, then it might not be worth as much. But this is something else that I would throw out is that in general, the closer to the middle of a city you are, yeah, this is someone mentioned lot area may be more commonly rural. Yeah. The closer to the middle of a city you are, the more expensive real estate is in general, and also on average, the less yard you have, right? So I chose to like live pretty close to the middle of the city, and my lot is technically like 200 square feet or something. I mean, it's probably bigger than that, but it's very small, right? And if you go out into to the middle of Tennessee, where I'm from, you can get 50 acres for not that much money, but it's the middle of nowhere and it's not that much money, right? And so yeah, you have those really high lot areas in places that are really far away from the city. Is I think one thing that you would look at. Yeah, nobody cares about lot area. I mean, some people do, and they choose to go live out in the suburbs, right? But yeah, on average, that is cheaper. Yeah. Good. Okay, we are quickly approaching time, and we have so much to get through. Okay, let's talk about, we mentioned earlier we have some categorical variables, and we need to find some way to turn those categorical variables into numbers, right? Because ultimately, next time when we play with machine learning models, all of the things we feed into our machine learning models have to be numbers. So we're going to look at how we deal with that. Someone asked, could you show the no outlier code again? Absolutely. This is honestly one of the chunkier lines, and so it probably makes sense to spend another second looking at this. So actually, maybe we'll break this up really quick because I don't want to skip over this. So let's pull this part out. And so we're saying that we're going to take every number of bedrooms and subtract from the bedroom mean. And so this will say distance from mean. And let's just actually print this out. And then let's print out originally just our number of bedrooms. So we know our mean. Our mean is 3.8 bedrooms, right? On average, people have 3.8 bedrooms-ish, right? And so we know this place has 4 bedrooms. This place has 5 bedrooms. This place has 3 bedrooms, right? But so distance from the mean, okay, 3.8 is our average. And so 4 is 0.1674 away from 3.8, right? This is just saying how close are you to the mean? So we're just literally taking what you are and subtracting the mean. Now we're actually going to wrap this in the absolute value. And all this is going to say is if you're a negative, don't be, right? So now we're really just looking at distance. And we're just going to say this is how far away from the mean you are, not in what direction. So if you run this, the only thing that will change is all the negative signs will go away. Boom. Okay. So now we have the distance from the mean. And there are a couple of things that there are a couple of ways we could do this. We could literally just say, so let's go back here, say our distance from the mean, We could say anything that has a distance from the mean that is greater than like 30, right? If you are more than 30 bathrooms away from the mean, you're drunk, go home, right? We could just do that, and that would actually be fine, right? That would work just fine for us. So if we run that again, and we look at bathrooms, it does a similar thing for us, right? It just says, hey, if you're more than 30 bathrooms greater than the mean, like get out. We don't care about you. The only problem that has is that we had to pick the number 30. And so that's why we're going to use 3 times the standard deviation, which I think we had up here. Yeah. And so instead of saying if you're more than 30 bathrooms away from the mean, we're going to say if you're more than 3 times the standard deviation away from the mean, which is a way of just being a little bit more robust. But just that number right there, don't worry about it. We could just say 30, and we just get rid of things that are really far out there. And then the dot copy. Yeah. Yeah, the dot copy is important. I continually am forgetting dot copies. I'm glad that you were interested in the session and you're having a good time. It's fun to go on little tangents. I think so much of data science and machine learning is like like finding an idea and getting obsessed by it and then going down a rabbit hole, So I appreciate that y'all are going with me on all these rabbit holes. Also, I'm going to need a break in just a second. So maybe in a minute we take a break and then we come back and we try to hit the last points, at least for folks in the future. I don't think we have anything after this session. So I think that we should be good to go a little bit over. And I will, even though my throat is getting sore, I will do it for y'all because we're having a good time. Okay, cool. On that note, actually, I'm going to give one more chance to see if the fish cam wants to cooperate. And if it does, I will leave you on the fish cam while I run and grab some water. Fish cam. Okay, so, and let's say fish cam. Hey, the fish cam is back. Okay, and now let's get rid of my screen. So you can see the fish cam. All right, I'm going to drink some water, and I will be back very, very soon. All right, I'm back. That wasn't even that long. Someone is asking for help. I'm sorry. What do you need help with? I want to help. I also want to turn off this fish cam before it destroys my computer. Literally. Yeah, y'all are my favorite. Of course I will set up the fish cam for you. And I'll set it up next time too. Okay. Let's go back to me being small. Let's kill the fish cam. Oh, that's interesting. It is actually it's when the fish cam freezes that it starts causing problems. So the fish cam would just stay put. This feels like the dentist's office scene from Finding Nemo. Yeah, that's the vibe. That is the vibe. And let's get rid of the fish cam. Cool. That's fine. Anything that's not the fish cam. All right, we're back. You're no longer in Finding Nemo. Darla can't hurt you. Was that her name, Darla? Was the hello fishy? I didn't actually knock on the lens because that lens was expensive. All right, we're back. We reviewed outliers, which I think that's something I'm really glad that people commented because that's something that in my head it's like, oh yeah, I learned about outliers long ago, and did not realize that it is, or did not remember that it is kind of a deep, sticky topic. So I'm glad we kind of reviewed back over it. Okay, so now the big task for whatever time we have left, which I guess is however long it is until I just pass out, is turning our categorical variables into numbers, right? And so one method that we can use for this, and it's a method that I think is really cool, is what we call one-hot encoding. Some of you have probably heard about this. I'm scrolling on the bottom. This is called one-hot encoding. And in order to actually demonstrate this, I want to use an example. I'm going to copy my example over. So say we have a data frame with just one variable called colors, or called color. We show this. We have, okay, a tiny little table where our first record is red, our second record is blue, our third record is red again, and our fourth record is green, right? And so what we can do is instead of having these categories, we can turn this category that has three values, red, green, or blue, into three categories that all are binary. And you're like, okay, well, what is this going to look like? And it's going to look like, and I'm just going to copy over my data frame because I don't want to type it all out. It's going to look approximately like this. Let's print that out. So the first row, 0, is red. And so we have one column that says, is it red? And the answer is true. And the second column says, is it blue? And the answer is false. And the third column is it green? And the answer is false. And I also have totally made some errors here. There. Okay, maybe that's fixed. Yes, I think this is fixed now. So that's the first row says, is it red? True. Is blue? False. Is green? False. And the first row is red. Our second row is blue. And so the is red column says false. And the is blue column says true. And the is green column says false again, right? So hopefully you're kind of picking up what we're doing here. And the reason that it's called one-hot encoding is because in this encoding, only one of the columns should ever be hot, right? So we always have, in this case, 2 falses and only 1 true. So it's false that it's red, it's false that it's green, it's true that it's blue. And in this third row where it's red, it looks the same. It's true that it's red, it's false that it's blue, it's false that it's green. And then in our fourth and final column, or final row where it says green, it's false that it's red, it's false that it's blue, and it's also true that it's green. And you might be saying, hey, Will, you said we need to turn these into numbers, and these are not numbers, these are trues and falses. And the answer is like, yeah, sure, but trues and falses are close enough. And the thing that we do is we just say true is equal to 1 and false is equal to 0. And this just ends up working actually pretty well. Just to say that true is 1 and false is 0. It's something we do a lot in a lot of computer science, because that works out for us. So this is the idea. Do we have any questions about one-hot encoding? Because this is like definitely one of the trickier, meatier concepts that we have today. No questions. We get it. Incredible. One question I would have is, okay, how do we do this, right? Like I see that this looks cool. I understand what's going on. How do we actually one-hot encode our own variable? And the answer is that pandas actually makes it really easy. So there is a function called pd get dummies. And the way you're thinking about it is that these are our dummy variables, right? Okay, we'll loop back around in a second to Neon's question. Get dummies, we're going to, in this scenario, we could just pass it our data frame colors, our original data frame colors. Oh. And then we could say the columns that we want to one-hot encode and just create a list of those. And we just say the column color. And if we hit return, then boom, it gives us basically the equivalent here, right? It may have, so it mixed up which columns are, like it mixed up the order of the columns, but it still stands that the first one is red, the second one is blue, the third one is red, and the fourth one is green. And so we'll use get dummies to sort of turn our categorical variables into sort of binary one-hot encoded columns. That's where we're headed in just a second. So Neon asked, why are we mentioning bedrooms? And so the reason is back up here. If we go back up to our outliers. So originally we were mentioning bedrooms inside there. Really, we just took that part out and we're doing the bedrooms part right here, right? So we are saying, taking your bedrooms, getting the distance of the number of bedrooms you have from the mean. So really, we could say bedrooms distance from mean. Maybe the naming is a little bit better there. And so we're saying if your bedroom's distance from the bedroom's mean is less than some number, then you get to stay. That you're close enough to our average that we think that you're probably a good data point. That's kind of the rationale there. Good question. Okay, so getting dummy variables. We have done this and we've played around with our toy data, but now we actually want to use it on some real data, right? And so the thing that I am going to propose is that here are a lot of our variables. The sort of the art and the science of machine learning comes in here, where we think about what variables are good for one-hot encoding. And the answer here is that usually you don't want to do one-hot encoding on things that have too many distinct values, right? So, okay, home type, we only have 4 values, right? It's either a single family, condo, townhouse, or multifamily, which means we would have to add 4 columns if we want to hot encode. There'd be one column that says, is it a single family home? There'd be another column that says, is it a condo? There'd be another column that says, is it single family? And there'd be a 4th column that says, is it multifamily? Sorry, is it townhouse? Is it single family? 4 columns we would have to add. What if we wanted to do one hot encoding for the state? How many columns would we have to add? Any guesses? Yes, someone guessed 50. We're technically 51 because we're adding DC. I'm just going to see a comment that says there's something called get dummies. Yeah, so we have get dummies is right here. That's the one we're using. Yeah. So someone asked, how is one hot encoding useful? In what scenarios will it be useful? And really the answer is that because we have to turn all of our variables into numbers, it is just a way that allows us to keep information from one of our variables, right? So scrolling back up to, let's look at train no outliers. Let's look at this one again. Okay. Head. So right now, if we wanted to feed our data to a machine learning algorithm, we would just have to get rid of city, state, and home type, right? We would just have to drop all of those. And then we would have there'd be no predictive power from home type or state or city, right? And so the reason that we do one hot encoding is just because it allows us to continue to use that information and give our model that information in a way that our model can understand. So this is like a lot at this point where we're not so much cleaning our data as we are preparing it for a model. And I think this is like a good question because it's like, there's nothing about this that's like for us easier to understand. It's just easier for a machine learning model to understand. So good question. That's kind of my quick take there. Okay, there is something called get dummies. Yes. Someone's mentioning the drop first equals true parameter helps the model not predict the outcome of the get dummies. So this is like an interesting idea where, I think the idea here is that you wouldn't want your model that gets fed sort of the get dummies of home type. So actually, let's just do this really quick. Let's say PD get dummies. We'll feed it in our data set, and then we'll say columns, and we'll just look at home type. So it's actually, it adds all the rest of our columns, but then we have, this right here. And we can scroll over to take a look-see. And in general, like you wouldn't want your model just predicting what home type is it, right? You wouldn't want it just doing that. I think in this scenario, we won't have that problem because we are predicting price and it's not intrinsically tied up in that. But it's a good question. Something I actually want to read more about to have like a better answer. But I think that is my take on that. Let's see. Yeah. So if we did it on, so coming back to the when is this actually going to be useful? And one of the keys is that we only have to add 4 columns here to one hot encode home type. We would have to add 51 columns if we wanted to one hot encode all of the states plus DC, right? That's more columns. What if we wanted to encode, if we scroll back over, what if we wanted to one hot encode the zip code? How would we do that? Or how many columns would we need? Well, the way that we'd find out is we would try to find the number of unique zip codes, right? So if we do train no outliers, we bring it down. We say zip code. I think you can just say unique, and then we could just say length of that. There are 7,301 zip codes. So we would have to add 7,301 columns. There are some ways of getting around this, but in general, you would have to add all those columns, and that would make a lot of your a lot of your other problems later just bigger, right? It would be kind of harder to train. You'd have more of a chance of overfitting. There are a lot of problems that could pop up if you use one-hot encoding on a really the frequencies. If your per value frequency is too low, it could just create problems. It actually ends up making your data set just really large, right? You're adding 7,000 columns, and it's going to be 0 for like all but one of them in all of your rows, right? So we're on one-hot encoding. One-hot encoding for condo or for home type, I think actually works really well. So I'll say train home type encoding. Now, A Joey says maybe turn it into a binary category. I'm interested in actually if you could describe what you're talking about a little bit more, because I think what you're saying might make sense. I'm just not 100% sure what you mean there. So we've now taken home type and we can actually use it. I will say, I think that state, we actually could one-hot encode. We could turn state into 50 columns. 50 columns is not that much. That would probably be viable. But for zip code and city, I just really wouldn't recommend it, right? There are too many unique zip codes. Okay, so somebody says, okay, this is kind of a cool idea. We can try visualization of zip codes as clusters and put them accordingly into clusters. That's, I think, kind of a cool idea, and I think it's something that that I would recommend you try. It is not what we're going to use. Somebody else mentioned label encoding, also a great option, one we're not going to talk about today. But what we are going to talk about is, can we introduce additional data? Okay, actually, one of my favorite comments of the past couple comments, do we need zip codes? Can we just remove it? And the answer is that's actually a really good thing to consider, right? We're going to look at building our model. It's really good to see, can we get by without this column, right? Zip codes are a little bit messier than some of our other data. And if we could get an accurate prediction with just bedrooms, bathrooms, living area, lot area, then that would be ideal if we could keep our model simple. But I do want to look at one other method. We've mentioned a lot of methods. We've got a lot of cool ideas. And I think a lot of them actually would be useful. Label encoding, trying to find visual clusters. Somebody mentioned something else. But we could also just drop it and just build our model off of these nice little numbers here. But the one thing that I'm going to suggest is that we try to introduce some additional data that makes this whole process easier. And so the idea is that I want to start by asking, why is zip code important? And we've mentioned this a lot. There's this adage in real estate that location is the thing that matters. But why does it matter? And I mean, there are a lot of different reasons that we can answer this. I mean, one of them is the idea that I live in the city, and that's because I want to be close to a job, right? I love my job at Google. It pays really well. I want to be close to it. And that's why I really like my zip code, right? And in general, this is a thing we see, is that in some zip codes, there is sort of a lot of high-paying jobs, and the property there is really expensive. And in other zip codes, there might not be as many high-paying jobs, but the real estate prices are a lot more affordable. And so what I might throw out is that, well, hey, if we could get the average household income for each of these zip codes, then that actually would be a valuable piece of data to replace zip code with. And so it actually tells us something about the zip code as opposed to just giving us the label. And so this is, I think I'm going to call it and say this will be the last thing that we do tonight, and we'll just charge through it, is that we are going to go and we're going to steal the census. We're not going to steal the census. We're going to borrow the census's data because they are willingly giving it to us, right? So we talked about one place to get data is Kaggle. Another place to get data is census.gov. Now, in case you're not familiar, in the US, every 10 years, we hold a census where we go out and we ask everybody in the US questions, right? And we ask questions like, who are you? Where do you live? And you usually answer hey, you found me, I live here. But they'll also ask questions like, what do you do for work? How much money do you make? Do you own your home? Stuff like this. And we can actually get this data and use it to our advantage. Another note I want to throw out, someone mentioned we could get latitude and longitude from zip code. This is fair as well. We'll talk about why that might not be a good idea later when we talk about capacity. but hold that thought. It's a good thought. So we're over on the census website. I'll admit the census is a little bit hard to deal with sometimes. The data format they give you things in sometimes isn't the cleanest. But hey, it's the government. They're doing it for us. The data is here and accessible, and so I will not complain. Where we're going to go, if you want to go follow along with me, you can go to census.gov. Okay, you're getting it with a comma or with an apostrophe, and then you're getting it without an apostrophe. So you're welcome. Census.gov, and then let's come down to explore data. I'll actually make this a little bit bigger so it's a little bit easier to see. And we'll say explore main data. Then we can click on tables and maps. And then there are tons of things you can look at here. So maybe we'll just search for median income and see what pops up. Median income in the past 12 months. Okay. So what I want is if you click right here in this tiny little drop down, also, you don't have to follow along. You can just see where I'm getting this. And we'll scroll down to the 5-year estimate, because I think maybe there are ups and downs year to year, but the 5-year sort of average of the average income in a place, maybe that's actually useful, right? So now we see all this data for the whole United States. And you can see, okay, like broken down by race and by 2- and 3-person families and all of these details. But what I really want is based on zip code. And so if we go to geo and you go to, I believe it's zip code tabulation area, then you can click on all 5-digit zip codes within the US. Now, this is, of course, massive, and so you really wouldn't want to try to make your web browser display this because it would make you cry, or it would make your web browser cry. It would probably do to your web browser what my Fishcam did to my computer. But you could download this, and you would then have that data. Because I'm doing one of those like pulling the finished cake out of the fridge right after we finish putting it in the oven. I'm doing one of those things. I actually have already pulled this data and done a little bit of cleaning for us. And so it is actually on my GitHub. Hello, Manavi and Sunil. If I was mispronouncing your names, I'm sorry. Please tell me that I mispronounced them, and I will try harder. Incredible. So if we go back to GitHub, actually, you don't have to go anywhere. I'll just drop the link for you. So I have put the raw median income by zip code CSV on my GitHub, which means we can use that same trick of saying pd read CSV, plopping in our URL. We can say median income by zip code, it equals, and we can say .head on that. And great. So we now have a really simple CSV. I'm sorry. Okay, I'll give it one more shot. I don't know how I pronounced it the first time. I can see the accent on the Manavi, or I could see Manavi. Or I guess the third option would be Manavi, but I don't think it's Manavi. So I'm going to maybe go with Manavi. But I will just again apologize because I'm sure I'm getting it wrong. Usernames especially are hard when you're not even sure if like this is the full name or not. So here is our data. We have in one column the median income, and then in the other column the zip code, right? We can also see this problem of, because there were probably originally a lot of zeros in this zip code, all the zeros at the front get kind of lopped off. Oh, incredible! I got it right the first time. Lovely. This is a little bit tricky, but the good news is that that all the zeros will have been dropped from our original data too. And so what we're going to do now is we're going to try to merge those data sets together. And this, actually, I'm going to have to look at my notes to remember exactly how we do this. We use the handy dandy pandas merge function. So we will say pd.merge. And so basically we want to say, from this data set, see your zip code, find whatever column your zip, or whatever row your zip code is in this data set, and then replace it with that number, the median income. So we will have the median, every zip code will have its own median income. So we will say PD merge will include our first data set, which is train no outliers. It will include our second data set, which is our median income by zip code. Then we will have to say how. And this kind of gets into sort of SQL norms. But basically, we want to say that train outliers, our left data set, is the one we really care about. And we're trying to merge this into it. And so we're just going to say left. And the way that you should think about this is that we're just telling the merge function that this is the important data set and that this is the one that we want to keep afterwards. And so then finally, we will say we'll have a parameter called left on. Oh, we can even read the parameters here. And we'll have a parameter called right on, which means what columns need to match. So in our left data set, train no outliers, the column is just called zip code. So we can say left on zip code. And then in our right data set, median income by zip code. It looks similar, but there's an underscore. So we'll say right on zip code. And this will give us the merge. Someone's asking, is this like a left outer join in SQL? Yes, absolutely. This is the same thing as a left join in SQL. If you know some SQL, Pandas has a lot of constructs that are really similar to SQL. If you don't know SQL, don't worry about it. It'll all be okay. Cool. So now we should be able to, we can call this our merged DF. And maybe we run that and we just say head at the bottom here. And this might take a second, but now we have for each of our rows, we have the original zip code, but then we have the median income there, right? So for this house, it's in a place where the median income is $46,000. And that is now actually a valuable piece of information that might actually help us when we're trying to predict the housing price. And now we can get rid of zip code, basically. That's kind of the long and the short of it here. So maybe for our last act of the night, we will say merge df drop, and we can drop both zip code. And then also we got this other zip code in here, which those should just always match. And so we can say merged df equals, and then we'll do, well, I don't think we should have to copy, but we can say axis equals 1. And boom. Okay. So I want to really quickly recap. We're now technically, well, probably 10 minutes over formally because we started 10 minutes late. Hannah, thank you for the reminder to drink some water because, gosh, I needed it. Incredible. So I want to recap a little bit. We went and we searched for data and we evaluated different data sets. We saw that a lot of the data sets, they just were too limited. They were either too small or they only concerned a single city. And both of those were problems for the task that we wanted to do. We then found a data set we liked, you're welcome, and we imported it and we started looking at it, right? We saw that there were some outliers. We saw that the lot area, some of them were in square feet, but some of the lot areas were in acres. So we converted that all to square feet. We also got rid of the outliers in the bedroom category because we had that one house that had like 15 million bedrooms. And that was just not going to help us because it would do all sorts of weird things to our model. And then we finally looked at how to deal with categorical variables, right? We looked at two different methods. We looked at one-hot encoding, which is where you say, instead of is it red, green, or blue, you say one column, is it red? One column, is it green? And another column, is it blue? That's called one-hot encoding. And then this last thing we did is we thought about, are there other sources of data that we could merge into our data and learn more about what we're trying to learn? And in this case, we felt like the median income in a zip code was probably relevant to the price of housing in that area. And that's kind of an assumption we made. And so we brought that in. So now we are in an incredible place to, next time we meet, to really just jump right in to throwing interesting models at our data. So thank you so much for coming. We are basically at a close here. I'll do a little bit of some sort of closing housekeeping. So first of all, I want to drop again the feedback. The secret word, if you want a chance to name one of my fish, is acre. So just send the response in there with the word acre. Oh, thank you so much, everybody, for the sweet words. You were all too kind. The other thing that I want to throw out is I just want to put on your radar the next live stream. So I will really quickly find that. Local hack day, MLH, build, schedule. I really should have this link already ready. But so this is going to be actually on Friday. It's going to be 2 hours earlier than this one was. So I won't even try to tell you what time it is because time zones and stuff. But I would love it. Oh, Hannah, you're already there with the link. You're constantly saving my life. And so you can sign up for that one. That's when we really get to the cool actual machine learning parts, right? So we got our hands messy with data. And I think that it's true that most of machine learning is actually cleaning your data. So I think it's really important that we had this session together. But next session, we just get to throw stuff at it. We get to throw linear regression and random forests and artificial neural networks if we want to. And we really get to go nuts. The one or a couple other links that I will throw back is that if you want to sign up for our competition, you can sign up for it on Kaggle. I think that is, I don't think I'm forgetting anything. I will just reiterate that it has been a blast. There's no way that I would rather spend my Wednesday night. It has been a joy. The questions have been incredible. All the feedback has been really, really great. And I think on that note, I will maybe play us out on Kalimba, and we can all go our separate ways until next time. All right. Thank you so much for being here. It's been a blast. Last question. If you want to drop in the chat, what song I should learn to play on the kalimba? I know last time I did All Star by Smash Mouth. If you have any other thoughts, definitely do that. Oh, also thank you so much for everybody that sent me feedback in the forum or connected with me on LinkedIn. It was super fun to get all your messages. Please keep it coming. Ooh, Harry Potter theme song from 2 people. Those are both, that's a great recommendation. I will add that to my list. Harry Potter theme song. But yeah, like drop all your thoughts. You could also drop them in the forum. You can follow me on the internet at WLiffert. It's, right there if you want to. But yeah, it's been a blast. And I will keep reading these comments. But thank you so much for being here. Thank you for your engagement, and happy hacking, fam.